definition. The set of all bracket quoted in the first bracket quoted. A set of all P of x such that x belongs to V. Okay. So in here null space it will be set of all x. Okay. For A, what it will be? Set of all P of x. Where x belongs to V. Okay. So this is the last topic what we have discussed, and we discussed in one problem how to identify the nullity and rank. What is nullity? What is nullity? What is nullity of P? Dimension of null space. Dimension of n of P is called as the nullity of P. What is rank? Dimension of age. That is called as the rank. What is the dimension theorem? Dimension theorem. Rank of T plus nullity of T should be equal to dimension of P. Okay, that is called as the dimension theorem. Okay. Already we discussed one problem. Still we will be discussing two problems maximum. Then we will go for the next concept of 1, 1 and onto function. What is the first problem we discussed? What type of problem? Is it a polynomial or a matrix or what? First problem, huh? C and what goes? Vector. We discussed the first problem based on a vector. Okay. So what is for V and W given? R square to R cube. Okay. Second order pair to the triple order pair. That is the first problem what we have discussed in your last class. Okay. So let's discuss some more problem. Then we will go for the next one. So take down let let V be the vector space. Let V be the vector space of let V be the vector space of 2 by 2 matrices. 2 by 2 matrices over R. 2 by 2 matrices over R, and let M is equal to the matrix 1, 2, 0, 3. 2 by 2 matrix 1, 2, 0, 3. Let T from B to B, T from B to B be the linear mapping. Be the linear mapping defined by T of A equal to AM minus MA. AM minus MA. Find the basis of kernel of T. Find the basis of kernel of T. What is kernel now? Yes? Null space. So the alternative name for null space is our kernel. So here nothing but it identifies the corresponding basis of the null space. So what is the condition for null space? That's now very important. T of x should be equal to 0. The transformation value should be equal to 0. Based on that one, we identify the set of bases. Okay, with that basis only we identify what is the line Right, next one. N of t equal to n of t is equal to the set of all matrix of the form x, y, w, z such that t of a will be equal to 0. This will be our lemma. Generalized matrix here assembly. Such that t of a will be equal to 0. Right? That is transformation of the matrix x, y, w, z should be equal to 0. That is the condition. We are assuming a generalized element for our null space. Okay. Now what is the transformation formula? Am minus md. This is our A, and we have given already what is M. So in this equation we are going to replace both A and M, equate it to 0, and we are going to find what is the values for x, y, z and w. Okay, because that one will give us our basis, the combined values of x, y, z. Whatever possible values are there, all the possible values we have to discuss. That set only will give us the corresponding basis. Okay, so that given t of a equal to am minus md. Am minus md. Therefore, transformation of x, y, w, z is equal to, this is our a. Now replace a and m. A is x, y, w, z, and what is given to m? 1, 2, 0, 2, minus 1, 2, 0, 3 into x, y, w, z. This should be equal to what for null space? Yes, it should be a null matrix. It is not a single value, it is a null matrix. So now you have to solve this and define what is here x, y, z and w. How will you solve now? This way is what? Matrix multiplication. How will you do matrix multiplication? First row into first column, then first row into second column. Tell me what you are going to get. X 2x plus 3y. Can everyone understand? This one into this one. X into 1 will be x, y into 0 will give you 0. Now the first row into second column. 2 into x will give you 2x plus 3 into y will give you 3y. Now similarly do it for your second row. What you will get? W 2w 3 plus 3. This is our first matrix. Minus. Now multiply for a second one. Here first row into first column. So what you will get? X plus 2w. Now first row into second column. Y plus 2z. Now similarly do it for the second row. 3w. And this one will be 3z. This should be equal to the null matrix. So what is the next step you will do now? This is matrix subtraction. Do the subtraction. So what you will get? First element with first element. What happened? Minus 2w plus 2w. Minus 2w. So it will be minus 2w. Next one. 2x plus 2y plus 2y minus 2x. So 2x plus 3y minus of y plus 2z. Okay. Now second row minus 2w minus 3w minus 2w. Now the last one 2w plus 3z minus 3z. 2w. So everything should be equal to our null matrix. Has anyone written up to this one? Because I got to erase this one. Have you written? Now just combine and find what is x, y, z and w. Equating the coefficients, the corresponding coefficients. Yes. What is the obvious one you will get? x plus y equal to ez. If you want, you can rewrite like this. With this one equation, can you find x, y, z? Not directly. But what is the other way of finding the solution? Our trial and error or our assumptions. So what is the basic assumption you will do? What are the values you will assume? Either 0 or 1. Combinations of 0 and 1. Just identify a generalized solution. Yes. So what you can assume to be 0? X equal to in actually and the more value contributing number 2 da. Now because z is dependent on x and y. So if you know x and y, you can find z. Is or no? So what are the two values you are supposed to find? Only x and y. So fix that trial values for these two values only. What are the possible values? 0 and 1. It can be x equal to 0 or it can be y equal to 0. Whether both can be 0. If both the 0 is what happens? All variables will become 0. It is a very trivial solution. Okay, but choice is another trivial solution assume one. If you assume x0 and y0, what will happen? Z is also 0. W is also already 0. Okay, it is a very trivial solution. So ignore both the cases to be 0. Okay, take the alternative. What will happen when x equal to 0 and y equal to 1? Or what will happen when y equal to 0 and x equal to 1? Don't take all the values to be 0. It is a very obvious one. Okay, so take down. So when x equal to 0, so not when, then x equal to 0 and y equal to 1. So what happened to z? 1. Z will become 1. So now we assume x equal to 1 and y equal to 0. What happened to z? 1. So only this way is going to vary. Z is going to remain the same. Okay, tell me what are the possible solutions now? How many variables we are having? 4. X, y, z and w. Okay, tell me what are the possible solutions? What is the first possible solution now? X is 0. Y is 1. And z is 1. And w is 0. Matrix. We are trying to find the basis of it, not matrix. We are trying to find only the basis. This is one possible basis. What is the next possibility? Is that 1 0 1 1 0 1 0 1 0. Okay. So how many bases we are getting? 2. So these are the basis for our null space. Can you understand? Don't go for obvious solution, ma. Okay, previously it was a direct solution, no other possibilities was there. So only we consider the previous solution 0, 0. But here there is a possibility. So don't go for previous solution in all the problems. Okay, can you understand how to identify the basis? So right, hence the basis of the null space. Hence the basis of null space is equal to the set 0 1 1 0 1 0 1 0. These are the corresponding bases for our null space. Can you tell me what is nullity of T? For this problem, what is the nullity? 2. What is nullity? Dimension of n of T. How many elements in n of T? 2. So nullity of T will be equal to 2. It is not ours direct, but even there. So you are supposed to find only the basis of kernel. We are completed. That's all. Okay, no need to find the nullity, no need to find the nothing else is needed. Okay, any doubt now? So this type of problems is also possible like trial and error. Okay, direct solution is not possible. In some cases, you have to assume a solution and then you have to wait for all the possible cases of the solution. Is it clear? Any doubt in this problem? Okay. I will give you one more problem which will be a practice problem at home. Okay, so take down. Still anyone copying? Let's start with the next one. Okay, take down. Let T from P3 of R be? Polynomial of third degree or third order. What is P2? Second order. Polynomial of second order. How will be the elements in P3? That form how will you write? A0 plus A1x plus A2x square plus A3x3. That is the general form. How to write for P2? A0 plus A1x plus A3 plus A2x square. Polynomial of second degree. Okay, continue. Defined by transformation of f of x is equal to f dash of x. Transformation of f of x is equal to f dash of x. Find the nullity of p. Find the nullity and rank of p. Find the nullity and rank of p. Okay, no? Can you understand? Yes, we have defined both the nullity as well as the rank. How will you start? To find nullity, what is the first one you have to find? A is for a null space. What is the condition for null space? P of f of x should be equal to 0. How will you assume f of x now? From P3 or P2? Here f of x will be from P3 or P2? P3. This is our P and this is our W. Okay, from this one only we are going to have to the order form. So how will be your f of x? Third order polynomial. Okay, assume a generalized one. Okay, so what is the condition? F dash of x. This should be equal to 0. So if you differentiate that, what you will get? What is the third order polynomial? A0 plus A1x plus A2x square plus A3x2. Okay, for null space, f dash of x should be 0. This is our f of x. When you differentiate that, what you will get? A0 will become 0. A1x, A2x square, 2A2x. A3 into x cube, 3x. That should be equal to 0. Okay, well, from this you have to identify the values for A0, A1, A2, A3. Can you identify what will be the values in our code? 0. Because the polynomial should be equal to 0 in our code. All the coefficients should be 0. But now the polynomial 0 polynomial 0. But now what will be your answer? A0, A1, A2, A3. Sorry, not A0. You will get A1, A2, A3 to be 0. In f dash of x, A1, A2, A3 must be 0. Okay, we having only one value left out. What is that one? A0. Now null space in our. That is the element of null space. I am explaining the problem with them so that we can solve it. You understood, no? F dash of x equal to 0. So what you will get? A1, A2, A3, 0. After mixture element in our A0. So how many elements will be there in the null space? Only one element. What is that element? A0. A0 can be any constant. We can't say that it can be 0 or it can be 1 or it can be 2. So A0 is generalized constant. Now the trial or error solution conducted 0 or 1 cases in discuss. This is generalized value. A. அப்படி என்ன வரும் 3 3. The dimension will be equal to 3. Not dimension, the rank of T will be equal to 3. Is it clear everyone? Yes. So previous problem பார்த்தீங்கன்னா அதுக்கு தனியாக ஒரு ப்ரொசீஜர் போட்டுருக்கோம். பட் இது பாலினாமியல் இருக்கிறதுனால இது தேவையில்லை because we know that it is going to be of this form. Okay, so we are writing the generalized one and from that directly we can say that rank will be equal to 3 because it is here second degree polynomial with 3 constants. Okay, அதுதான் நம்மளோட basis setல வரும் a0 a1 a2. So the dimension will be equal to 3 ன்னு கன்சிடர் பண்ணுவோம். Okay, can you understand how to solve? Any doubts? Any doubt now? Okay, we'll go for next problem. Next one. See ma, I have given you all the explanations. So next class I want everyone to complete the problem for the class. Okay, I told you all the steps what you are supposed to follow. Okay, right? Find the range space. Find the range space, comma, kernel. Find the range space, comma, kernel, comma, rank. Range space, comma, kernel, rank, and nullity of the following. Nullity of the following linear transformation. Nullity of the following linear transformation. Also verify the dimension theorem. Also verify the dimension theorem defined by T from V3 of R to V2 of R. V3 of R to V2 of R by T of E1 equal to 2, 1. T of E2 equal to 0, 1. T of E3 will be equal to 1, 1. So this one problem covers all the topics what you have discussed so far. What are the things you have to find in this problem? Range, null space, or kernel, then rank of T, nullity of T, and then you have to verify the dimension theorem. Everything combined under one problem. But there is a hidden thing we have to find one more. What is that one? It is not given directly, but only if you find that one, you can solve the problem. What is that? Yes. Say in order. Linear transformation. That relation is not given. Whether it is given, not given. In all the previous problem, you are given what is T of x. It is defined or not, but in this problem, it is not defined. So first, you have to find what is the linear transformation. Only if you know what is the linear transformation, you can find what is the corresponding null space. So you have to find the linear transformation also. So whether all the topics are covered or not? Yes or no? So what is the first one you have to find? Linear transformation. Based on that one, it is find what is the null space and what is the range. Based on that one, you have to find what is the nullity of T and rank of T. And final step, you have to verify what is the dimension. Okay. You all remember how did you find the linear transformation? You have to assume here standard basis. That is what given here as E1, E2 and E3. You have to assume the standard basis. Okay, well, then you have to find a generalized one from our B. Generalized element from our B. Then you must try to represent it in terms of E1, E2, E3. The generalized element will represent them in terms of our standard basis E1, E2, E3. We will substitute T of E1, T of E2, T of E3. Then we will get our generalized formula. That is the procedure for getting our linear transformation. That is the first step we are going to do. Okay, start the solution. is not given, comma, find the linear transformation. Find the linear transformation. So how do you find the linear transformation? You have to assume the standard basis for our V. Okay, what is our V here? V3 of 1. Okay, how will be the elements here now? Triple order. Okay, triple order elements because we are in our V3. Okay, so what are the bases for that one? 1 0 0 0 1 0 and 0 0 1. So right, the standard basis of R cube is the standard basis of R cube is beta is equal to 1 0 0 0 1 0 0 0 1. The standard basis. So right, let E1 equal to 1 0 0, E2 equal to 0 1 0, E3 equal to 0 0 1. We will assume the standard basis as E1 E2 E3. Do you all remember what is the next step we are supposed to do? We have to identify the transformation. Okay, we have to assume a generalized element from our V. Okay, how will be the generalized element? This is the standard basis. Assume a generalized element. How can we assume? R cube, x1 is there or x1, x2, x3 or a, b, c. Not one. Generalized one. Not specified one, generalized one. Some triple order pair a, b, c or x1, x2, x3 or it can be x, y, z. Any notations, it should be of the triple order. That should be written in terms of our E1, E2 and E3. So right, let x1, x2, x3 belongs to R cube. We assume a generalized element. Now rewrite this in terms of our standard basis. You all over how do you write this? Standard basis. E1, E2, E3. Yes, x1. x1 order which basis can be multiplied? A1. For x2, A2. For x3, A. So this is equal to x1 into 1 0 0 plus x2 into 0 1 0 plus x3 into 0 0 1. If you know this, you can write it directly also. So x1 E1 plus x2 E2 plus x3. Okay, writing the generalized element in terms of the standard basis. Now what is your objective? What you are trying to find? What you are trying to find? Linear transformation. So apply the operator P on both sides. So right, therefore transformation of x1, x2, x3 will be equal to x1 into transformation of E1 plus x2 into transformation of E2 plus x3 into transformation of E2. Applying the transformation operator on both sides. So in this question, you are given what is T of E1, E2 and E3. Substitute that in your RHS, simplify, that will be a linear transformation equation. So substitute and simplify. So x1 into transformation of E1 is 2, 1 plus x2 into E2 is 0, 1 plus x3 into E3 is 1, 1. Tell me what is the relation? Vector, simplify. 2x1 plus x3. 2x1 plus x3. copying? Okay, right. N of t equal to the set of all triple ordered pair x1, x2, x3 such that t of x1, x2, x3 equal to 0. That is t of x. Here instead of singleton element we are having a triple ordered pair. So equal to 0. Tell me what is x1, x2, x3? T of x1, x2, x3 should be 0. But what is the transformation? 2x1 plus x3 comma x1 plus x2 plus x3 should be equal to 0. Tell me the values. x1 is equal to 2x1 is equal to minus x3. Okay. Then x1 plus x2 plus x3 equal to 0. What is the other way you can solve? There is 3 unknowns. Can you reduce it to 2 unknowns? x1 is equal to x1 equal to x3.
Minus 63 minus.
Yeah, this is equal to minus. From x1 x3 is equal to minus x1 minus x2. This is equal to LCM. Okay, but no need to confuse whether it is LCM or any denominators. Any other way also you can do this. Okay, how can we reduce it to 2? x3 equal to minus x1 minus 2. So 2x1 is equal to x1 plus x2 because minus of x3. Okay, so we bring x1 to this side, what will happen? Yes, sir. If you bring x1 to this side, what will happen? x1, 2x1 minus x1 will give you x1. So what you will get from here? x1 is equal to x2. Okay, so what is the relation you are getting? x1 equal to x2 and x3 is equal to x1 plus x2. x3 equal to minus x1 minus x2. Okay, tell me what are the required values we can assume? x1 should be equal to x2. So what is the value you can assume for x1 and x2? Can you assume 0? Can you assume 0? Can you assume 0 or not? No, don't assume 0 because x1 should be equal to x2. So both will become 0. If this is 0, what will happen to x3? That also will become 0 to become as a trivial solution. So don't assume 0. Okay, wow. So what is the next value you can assume? 1. Let us assume x1 equal to x2 is equal to 1. So what happened to x2, x3? Minus 2. x3 will be equal to minus 2 from this equation. Okay, can you understand why you can't assume 0? Because x1 is equal to x2. So we assume both to be 0, x3 also will become 0, which is a trivial solution. So don't assume that. Okay, so write next line. Let x1 equal to x2 equal to 1. x1 is equal to x2 equal to 1. So that implies x3 is equal to minus 2. x3 is equal to minus 2. Therefore, basis of n of t is equal to. Tell me what is the basis now? 1, 1 and minus 2. x1 is 1, x2 is 1, x3 is minus 2. This is the null space. Tell me what is nullity of t? 1. So nullity of t is equal to 1. So what is the next one you have to find? Rank. To find the rank list you need the range. Already it is given. What is the transformation of E1 into E3? Put the idea. That right hand side is given. How it is going to get transformed? இங்க வந்து நீ அதோட பேசிஸ் கண்டுபிடிக்கணும். அந்த ரேஞ்சுக்கான பேசிஸ் கண்டுபிடிக்கணும். அது நான் உங்களுக்கு என்ன மெத்தட் சொன்னேன் ஃபர்ஸ்ட் ப்ராப்ளம்ல. என்ன மெத்தட் சொன்னேன்? Matrix. You write all the indicators in the form of the matrix. The number of non non-zero rows will be the corresponding bases. You remember for range? So rewrite like that one. Okay, already I have given what is E1, E2, E3. They are given the corresponding image. இது generalize தான் தேவையில்லை. ஏன்னா அவங்களே ஒரு 3 image அவங்க கொடுத்துட்டாங்க standard basis. நீ எதுவும் கண்டுபிடிக்கணும். So அந்த image வந்து you rewrite in a matrix form. Reduce it into an echelon form. The number of non-zero rows will be the corresponding bases. This is the procedure to get the basis for the range. For nullity, this is the procedure now. For range, matrix forms. Okay, so right. Next one. Given T of E1 equal to 2, 1. T of E2 equal to 0, 1. T of E3 what is given now? 1, 1. This is given. For range, this is the procedure now. You have to get the image of the standard basis. Here it is already given, so no need to find. Rewrite this into the matrix form. So A equal to. So first image 2, 1. Second one 0, 1. Last one 1, 1. Now you have to reduce this matrix to an echelon form. What is echelon form? Make as many numbers as 0. So here first step what we can do is that if you want to interchange auto or R3, that is our choice. Because it is already 0. Or if you want to retain this, retain it, that is your choice. Okay, what is the first step you have to do? With the help of the first row, first element, make the remaining first element 0. Already this is 0. You have to make this as 0. So what is the transformation? R3 is transformed as 2 R3 minus R. So there is no change in first and second row. It remains the same. Now third row, what is that one? 2 times of R3. So 2 minus 2 will become 0. Okay, then this will become 2 minus 1 will become 1. If there is possibility, you can use. Is there any other transformation possible? R3 what can be done? R3 minus R, because both are same. If you subtract, this is going to become 0. So what is the one more step we can do? R3 is transformed as R3 minus R. Okay, so subtract both 2, 1, 0, 1. 0 minus 0 will be 0. 1 minus 1 will become 0. Any other transformations? Where ஏதாவது element which மூணு non zero இருக்கு. அது ஏதாவது ஒரு element ஓட zero மாத்த முடியுமா? Without affecting other zeros. Possibility is there. So how many non-zero rows are there? 2 non-zero rows. So this 2 rows will be the basis for our range. Okay, can you understand now? Yes, don't get confused. Null space na range கண்டுபிடிக்கிறது வேற procedure. Range வந்து null space के basis கண்டுபிடிக்கிறது வேற logic. இங்க range ஓட கண்டுபிடிக்கிறது by matrix procedure. Okay, so right. The non-zero rows are the basis of R of T. Or the basis of R of T. That is, basis of R of T equal to the set of all elements 2, 1, 0, 1. So how many elements are there? 2. So what is that one? Rank. So right. Therefore, rank of T is equal to 2. Rank of T equal to 2. Now we have verify a dimension theorem. What is the dimension theorem? Rank of T plus nullity of T should be equal to dimension of V. V is the set in our left hand side. What is our V here? What is the V in our problem? V3. Okay, so what is the dimension of T3? 3. Triple order term. What is the dimension of V3? 3. If you add this 2, are you getting it as 3? Yes. So dimension theorem is 5. So right. By dimension theorem, rank of T plus nullity of T, rank of T plus nullity of T is equal to dimension of V. Is equal to dimension of V. That is 2 plus 1. Rank is 2, nullity is 1. That should be equal to dimension of V. That is equal to dimension of R cube. V3 of R cube. What is dimension of R cube? So hence verify. Hence verify. Any doubt, ma? Any doubt? Yes? Still you have not completed one part. What is that one? Range space. You have not found out what is the range space. So range space is nothing but the subspace generated by our image. Okay, range space is nothing but the subspace generated by our image. Image, what is the vector here? V2. That is R square. R square means what type of elements? Second order elements. So that is standard basis எடுத்து நீங்க அதோட subspace of represent பண்ணணும். அப்படி பண்ணினா it will become as the range space. Again here also we are going to take it for the standard basis. So right, last one. Range space is equal to what one? Whose space? Whose space is equal? Very good. Range space is equal to the subspace generated by we make any mistake. Subspace generated by 2, 1, 0, 1. 2, 1, 0, 1. R of two basis. 2, 1, 0, 1. Which is equal to x1 into 2, 1 plus x2 into 0, 1. So add both. Only array basis of generalized value. So what is this one? Relation. x1 plus x2. This will be the range space for us. So right. Hence range space is equal to set of all elements of the form 2x1, x1 plus x2 such that x1, x2 belongs to R. x1, x2 belongs to R. x1, x2 belongs to R. Range space தான கண்டுபிடிக்கிறேன். So அந்த range ஓட basis வச்சு general representation பண்றேன். அதுதான் உங்க range space. ஓகேவா? Any doubt? Range space is very rare case only. பத்தில ஏதாவது ஒரு problem தான கேட்கும். All the other problems will deal with null space, range, nullity of T and rank of T. In some problems we verify the dimension theorem. That is very easy. Just you are going to add if it is equal to the P, then it is verified, otherwise it is not verified. Okay, ma? Any doubt? Any doubt? Okay. Next one, what you are going to discuss is that 1, 1 and onto function. You are going to check whether our linear transformation is 1, 1 or onto. Okay, those also based on our same logic, nullity and rank. Based on nullity and rank only, you are going to give the conclusion whether it is 1, 1 or onto. Okay. Any doubt, ma'am? Any doubt? Next topic. 1, 1 and onto. 1, 1 and onto. You are going to discuss whether transformation is 1, 1 and onto or not. 1 to 1 and onto. Take down. W, let V and W be the vector space. Definition or general statement. We are going to discuss what is one and what is onto. Let V and W be vector space and let D from V to W. Let D from V to W be a linear transformation. Then first subdivision. T is 1 1. If and only if T is 1 1. If and only if nullity of T equal to 0. Second subdivision. T is on to if and only if rank of T equal to dimension of W. So what is the condition given? When it is 1 1, if nullity of T equal to 0. When it is on to rank of T is equal to dimension of W. What is W, ma'am? Left side one or right side one? Right side. What is the transformation? E to W. Okay, in dimension theorem it is saying it to be dimension of V. Here it should be dimension of W. If these two conditions are satisfied, there is 1 1 and on. When nullity will be 0, ma'am? 0 element. We are finding the basis for null space, no? That should be our 0 element. Okay, if it is going to have only the 0 element, then the nullity will become 0. The first problem what we discussed. Okay, ma'am. Then on to you move. You will find the rank. If it is equal to dimension of W, then it is a அதே திருப்பி ப்ராப்ளம் இல்ல என்ன கண்டுபிடிக்க போறோம்? What are you going to find? Again the null space. Again you are going to find what is the rank. Based on that one, you are going to give the conclusion that it is 1 1 and here also the problems are the same logic, no? In some problems transformation will be given. Okay, in some problems what they can do? Translation will not be given. You have to find the translation as in the last problem, and then you have to find what is the null space and what is the range. Is that clear? Shall we start with the problem? I will give you only the questions you can solve. Because the same logic. You are going to find the null space and you are going to find what is the range. What is your choice? Shall I give you the questions? Okay, note on the question. Let first problem. Let T from R square to R cube. Let T from R square to R cube by T of A1 A2 equal to A1 plus A2 comma 0 to A1 minus A2. This is the equation 2. It is mapped from R square to R cube. Find nullity of T. Find nullity of T. Rank of T. Find nullity of T. Rank of T. Continue. Yes. T is 1 1. Yes. T is 1 1. Question mark. Yes. T is on 2. Question mark. Yes. T is 1 1. Yes. T is on 2. things you have to find? Nullity, rank of T, and then you have to check whether it's 1, 1 and 1. So we start with null space. Okay, what is the condition for null space? T of A should be equal to 0. So right, start the solution. Let T of A1, A2 equal to 0. That is the condition for null space. This transformation should be equal to 0. That is, what is the transformation given? A1 plus A2. 0 to A1 minus A2. That should be equal to 0. So actually the 0 will be what now? Triple ordered one. Okay, because here is a triple ordered term. So if you equate, what you will get now? A1 equal to minus A2. And from this, A1 equal to A2. What we have values? Now what will be the values for A1, A2? Two simultaneous equations you are having. A1 plus A2 equal to 0. 2A1 minus A2 equal to 0. Solve. When it is not solvable, we can go for trial and error. What happened? A2 cancels out. What happened to A1? 0. So if A1 is 0, what is A2? We say solve பண்ண முடியாத கேஸ்ல தான் என்ன பண்றோம்? Trial possibilities போடும். Okay, so what are the values for A1, A2? 0. Both is 0. So this implies A1 equal to A2 equal to 0. So what is nullity? Null space?
0.
Null space is equal to the set of element 0, 0. Because both A1 and A2 are 0. So what is nullity of T? 0. So one part is open. Nullity is 0. So it is 1, 1 or 2? 1. So right? Since nullity of T equal to 0, since nullity of T equal to 0, comma, T is 1, 1. T is 1, 1. What is the next one you have to find? Rank. Previously, how did you find the rank, ma? When we are finding the basis for our range, the number of non-zero rows will become as the basis. Here that step is not necessary because you know what is the dimension theorem. Using dimension theorem, you find the rank here because it is possible. What is our left hand side be? R square. What is dimension of R square? 2. You know that one directly. So using dimension theorem, you find what is here? Rank. No need to go for that procedure and find the rank. Okay, so right. By dimension theorem, nullity of T plus rank of T is equal to dimension of B. So you know the nullity now. What is nullity? 0. Plus rank of T is equal to, what is dimension of B? B is our R square. So what is rank of T? 2. Rank of T is equal to 2. What is the condition for on2, ma? Rank of T should be equal to dimension of W. What is our W here? R cube. Okay, what is dimension of R cube? 3. Whether rank and this one are equal? So T is onto or not? Not. So right? Dimension of W is equal to dimension of R cube, which is equal to 3. There is a direct one, so we don't have a check one now. So right? Since rank of T is not equal to dimension of W, rank of T is not equal to dimension of W, T is not onto. T is not onto. or not, ma'am? Yes or no? To find the rank also, no need to go for any other procedure. Just take the help of the dimension theorem and complete it. Okay, any doubts? We want to try some more problems. Okay, practice problem. Take down one more practice problem. One more problem for practice. Take from same relation now. R square to R cube. T from R square to R cube. T from R square to R cube is a linear transformation. Yes, a linear transformation. Note down everyone. Note down the question. Yes, a linear transformation such that T of 1 equal to 102, T of 2 3 equal to 1 minus 1 4, T of 2 3 equal to 1 minus 1 4. Determine first subdivision T. Determine T. Second subdivision, find transformation of 2 5 and transformation of 8 11. Find transformation of 2 5 and transformation of 8 11. Third one, find nullity and rank of T. Find nullity and rank of T. Fourth one, yes, T is 1 1. Fourth one is T is 1 1. Fifth one, ST is on 2. ST is on 2. So whatever we have discussed so far comes under this one single problem. Is or no? Yes. So here what you have to find? You have to find the linear transformation T, that is not given. So first you have to find the linear transformation. Based on that one you have to find these two values. How will you find? How will you find 2 5? That is substitute x1 equal to 2 and x2 equal to 5. In that relation you have to find the answer. Then you have to find the null space, nullity of T, then rank of T. Based on that one you have to discuss 1 1 number. We don't even verify dimension theorem. Everything will come under one single problem. Everything is one single problem. Okay. So next last topic we are going to discuss how to represent the linear transformation in a matrix form. Okay, that is the last topic in our unit 4. We will discuss that in our